I'm going to demonstrate how to do a normal probability calculation problem. So the first problem says the distribution of blood cholesterol levels in a large population of people of the same age and sex is roughly normal. For 14-year-old boys, the mean is 170 milligrams per deciliter, and the standard deviation is 30 milligrams per deciliter. Levels above 240 may require medical attention. So they want to know what percent of boys have cholesterol above 240. So the first thing I do for these types of problems is, hang on here, let me get my pen ready. The first thing I do for these types of problems is kind of highlight the important information from the problem. So it tells us that the population mean is 170, standard deviation is 30, and we're interested in levels that are above 240. So X, the variable that we're measuring here, is blood cholesterol. And they tell us that these blood cholesterol levels in 14-year-old boys follow a normal distribution with a mean of 170 and a standard deviation of 30. So the next step is going to be to draw a picture, kind of sketch out a normal distribution, and shade in the area that we're trying to find. So I start, it says it follows a normal distribution, so I'm going to sketch out a normal distribution. The center of a normal distribution is always the mean, so I'm going to put 170 right there in the middle. And I know, because of the 68, 95, 99.7 rule, that 99.7%, or in other words, practically all of the data is going to be within 3 standard deviations of the mean. So I can mark off distances of 1, 2, and 3 standard deviations from the mean on both sides. So if I take that 170 plus the value of 1 standard deviation, which is 30, then I get 200. If I add another standard deviation, I get 230, and another one I'll get 260. On the other side, I'm going to do the same thing, except for subtracting 1 standard deviation each time. And I'll get my picture of what the blood cholesterol levels of these boys looks like. Now for my question, I'm interested in boys that have cholesterol above 240. So I'm going to mark off 240, about right there. And I'm going to shade in everything above that. So this shaded in area right there is basically the answer to my question. Normal distributions are continuous, and when we're finding areas under continuous curves, then the probability is just going to be the area under the curve, or the proportion is going to be the area under the curve. So unless any of you are calculus geniuses out there, then you probably don't want to be integrating to find that area. So instead we're going to use table A, which has areas under the standard normal curve. So in order to use that, the next thing that we need to do is we need to standardize our observation. So we standardize an observation by taking the value, subtracting the mean, and dividing by the standard deviation. So in this case, the value that I'm interested in is that 240, so I'll take 240 minus the mean of 170 divided by the standard deviation of 30. So if I do that, I end up with 70 over 30, which is 2.33. So this 2.33 is called a z-score, and a z-score tells you how many standard deviations your point is from the mean. So this says it's a positive z-score, so it says that 240 is 2.33 standard deviations above the mean. So from here, I'm going to go over to table A to look up the area that's associated with a z-score of 2.33. So here's a little snippet of table A. In table A, the values of the z-score are along the left-hand column over here, and also along the top. So the ones place and the tenths place you're going to find on the left-hand column, and the hundredths place is going to be found along the top part of this table. So our value, remember, z was equal to 2.33. So I'm going to come over here to 2.3. That takes care of the ones and the tenths place. And for the hundredths place, I'm going to come to the 0.03 column. So where these two intersect is the value that I'm looking for from the table. It's the area, or the percentile. So we get 0.9901 from our table. So back at our problem here, I'm going to write that down. So from our table A, we got 0.9901. Now, table A always gives us the percentile, which is the area less than our value. So 240 was our value. The table gave us the area less than that value, so that's actually the white area over here on our chart. But that's not what we wanted to know for this problem. For this problem, we wanted to know the area greater than that value. But using the fact that all density curves have an area equal to 1, we can just subtract the value we don't want from 1, and it'll give us the opposite value that we do want. So if I take 1 minus 0.9901, that's 0.0099, and that is this area that I'm looking for. Right there, and that's the answer to our question. So since this is a word problem, word problems have word answers, as you recall from your algebra days, then I always am going to write a sentence stating the conclusion. So I would say, in this case, the percent of boys with cholesterol above 240 is 0.0099 or 0.99%.